Today's discussion will be about what is an ohmic resistor and a non-ohmic resistor, and it goes back to Ohm's law, where you find that for a given resistor, given circuit, you measure the voltage, current, plot it on a graph, you get a straight line graph, and the slope of the graph represents the resistance, therefore giving us the relationship V upon I is equal to R, which is what is given as the statement of Ohm's law. Now, in this question, you ask what is an ohmic resistor? Well, very simple. Ohmic resistor is any resistance that obeys Ohm's law. Okay, so if you use say copper, okay, copper wire, and you perform this experiment, you will find that for a certain length of copper wire, the voltage and the current, the ratio of the voltage and the current, if you keep varying it, you will find that the resistance remains fixed. So therefore you can say that copper wire is an ohmic resistor. Aluminium, it will be an ohmic resistor. You can verify this experimentally. Okay, we have in our laboratory an alloy called nichrome. We make wires out of this, particularly for studying resistance. Nichrome wire is also an ohmic resistor. So in that sense, then you can ask the question, then what is a non-ohmic resistor? If everything is obeying Ohm's law, what will not obey Ohm's law? Now, non-ohmic resistors are obviously the ones in which V upon I is not equal to R. Okay, which means instead of talking in terms of what are the materials, we will explore it in terms of the graph. Okay, so what will happen in a non-ohmic resistor? If you set up the circuit, you put this non-ohmic resistor in the Ohm's law circuit, and then you measure the voltage and the current. Okay, so same things apply, current here, voltage here. A non-ohmic resistor, when you plot the graph, you will find that its best fit curve goes something like that. It's not going to be a straight line like in the case of copper, aluminium, nichrome. It's going to be a curve. Okay, which means that the slope, and I'm just checking, have you studied slope of curves also briefly in 10th standard? Do you know how to calculate the curve, the slope of a curve at any point, that is?
Yes.
You know that, okay. So that means the slope of the curve at that point will be a tangent to the slope at that point, correct? So this is the slope at that point. If you take another point, the slope of the tangent to that point is going to be different. So what is going to happen is that what this means, if the slope is representative of resistance, right? That means that when you increase the voltage, the resistance is increasing. What was happening in an ohmic conductor? When the voltage was increasing, the current was also increasing proportionately, so the resistance remains the same. Whereas in a non-ohmic conductor, the resistance is variable. It changes. When you increase the voltage, the current changes, not linear. It's not proportionate. Okay, so as far as your 10th standard syllabus is concerned, this is all you need to know. There is this one possibility where as the voltage increases, the amount of current flowing becomes higher and higher. Wait a minute, not higher and higher, lesser and lesser? Yeah, lesser and lesser. So therefore the resistance is increasing. Okay, it is also possible for some type of resistors in which this can happen. The resistance behaves in this manner. Okay, which means the slope at different points, the tangents, the slope decreases. okay, which means the resistance is going down. So both possibilities are there. In other words, V upon IR is not being obeyed. All right. So some examples that we can talk about in terms of variable resistance. There is one surprising thing. If the resistance heats up, so in the factors on which resistance depends upon, we talked about what happens when the temperature of the resistance goes up. What will happen to its resistance?
What, sir? Can you repeat that?
Sorry, can you just give a one-word answer?
No, I couldn't hear you.
I was saying when a resistor is connected to a circuit and the resistance becomes hotter and hotter as the voltage is varied. So what will happen to the resistance of that resistor?
It will increase.
It will increase, correct? So that means that the resistance is not constant. It is variable. Okay, that is this case actually. Right? So even when a resistance becomes hot, it becomes a non-ohmic resistor. So Ohm's law is applicable only for a specific range of temperature. You have to give a range X to Y. If the resistor becomes hotter than Y, then we are going to have a problem because that resistor is not going to behave like an ohmic resistor. And sometimes we get into trouble with that in the laboratory because we keep the current on for a long time. And then what happens is that the nichrome wire that we are using becomes hot. And when it becomes hot, then you get erratic values for current. The resistance increases. So it is important to quickly switch on the circuit, note down the voltage and current and switch it off. You can keep it on for 10-15 seconds. But if you keep it on for a long while, then you will actually heat up the wire. And when the wire heats up, the resistance goes up, and that is going to give you bad values to measure your, to verify your Ohm's law with. Okay, there are some other things. So heat is one thing that causes the resistance to go up. It will make an ohmic conductor into a non-ohmic conductor. But there are other devices like semiconductors, which also behave as non-ohmic resistors. And the details of that are given in the textbook. I won't go into it now. So we will stop here. If you have any questions about ohmic and non-ohmic resistance, then we can take it up.